Okay, 10.6 is mean and standard deviation of binomial probability distribution. Let's say you go into your government class and you have a pop quiz and you forgot. Actually, no, it's not. You didn't forget pop quiz. It's a surprise quiz, right? You haven't studied, so you're going to have to guess. It's not going to be 8. It's going to be a 10-question multiple choice with 5 options for each question. And you're a little happier because you know you can at least guess on the answers. And since it's multiple choice, you have a 1 out of 5 chance of guessing correctly, which is 20%. So pause for a moment and bubble in your guesses and think about how many answers you think you'll get right. Okay, so if you have a 20% chance of guessing correctly, odds are you'll get 20% of the 10 correct, which is 2. So now just for fun, let's say, we're going to pretend that's fun, okay? We're going to pretend this is something fun, just for fun. Pretend these are the right answers that I'm currently totally making up. Pretend those are the right answers and correct your quiz and see how many you get right. Basically, it's odds are it's pretty close to 2, and if it's not, if we found everyone in the class, if we averaged out all of your answers correct, that would be about 2. Okay, this works better in a full class setting, but here we are. If there were 20 questions on the test and you were still guessing, think for a second how many you would think you'd answer correctly. Well, 4, right? Because on 10 you got 2 right. For 20, you'd think you'd get about 4 right. Also, 20% of 20 is 4. So is the situation above binomial? Yes or no? Well, are there repeated trials? There are. You're answering questions. Fixed number of trials? Yes. There's 10 because there's 10 questions. 2 options, success or failure? Yes. You either have the right answer or you don't. Okay, so if the answer is B, it doesn't matter if you guessed A, C, or D, or E, you're wrong, right? Probability the same? Yes, because you're guessing. We're assuming you know nothing about any of the material, so your probability of success, P, is going to be 0.2. 1 minus 0.2 is 0.8, so the probability of failure is 0.8. Are the events independent? Yes. We're assuming you go from question to question and you're like, what's this one? A. What's this one? C. What's this one? E. And you're totally guessing. All right. So if a probability distribution is binomial, we can find the mean using n times p. Okay? Where again, n equals number of trials and p equals probability of success. Okay, so same variables that we used in the last lesson. So mean is NP. Recall from chapter 1, or maybe you don't recall. Pretend you recall from chapter 1 that standard deviation is the average distance from the mean. And if you had a big standard deviation, the data is more varied. We had a process for finding standard deviation, and it was long and kind of annoying. But when it's binomial, you can find it using the square root of NPQ. Okay? The variance is then NPQ. And again, N is number of trials, P is probability of success, Q was probability of failure. So let's rewrite this separately over here. So mu, which is mean, is NP. Variance, which was sigma squared, is NPQ. And standard deviation is the square root of NPQ. Pretty simple as far as formulas go. So we have Chris, a basketball player, who makes about 30% of the three-point shots he takes. If he takes 8 shots in a game, find the mean mu, the variance sigma squared, and the standard deviation is sigma. Well, N is 8, because he's taken 8 shots. P is probability of success. Well, we're assuming success is making your shot, so that's 30% or 0.3. And then Q is probability of failure. So, and 1 minus 0.3 is 0.7. So then mu is the mean, is NP, which is 8 times 0.3, which is 2.4. So about 2.4 shots on average. Obviously, you can't actually make 2.4, but that would be the average. Our variance is NPQ, which is 8 times 0.3 times 0.7, which is 1.68. Standard deviation is the square root of NPQ. So it's just the square root of our variance, which is 1.3. And that 1.3 means that on average, the number of shots he makes is 1.3 away from the mean. Now we have Savannah, the hockey player, whoever she is. Well, she's Savannah, I guess, huh? So Savannah, the hockey player, makes about 55% of her shots, and if she takes 7, we want to find the mean, the variance, and standard deviation. Well, N is 7. That's how many shots she takes. 55% is probability of success, because again, success is going to be making shots versus missing. Probability of failure is 1 minus 0.55, which is 0.45. So then our mean, mu, is going to be NP, which is 7 times 0.55, which is about 3.85. Variance is going to be 7 times 0.55 times 0.45, which is just NPQ, which is 1.73. And then the standard deviation is the square root of what we just got, which is 1.32. So on average, she makes 3.85 shots that she takes if she takes 7 shots in a game. Her average number of shots she makes is, her average number of shots if she takes 7 is 3.85 shots that she makes. And the average distance away from that mean is 1.32 shots. Pause the video and try number 3 for me, please. Okay, hope you tried it. So we have some binomial random variable. The mean is 40, standard deviation is 6. So if you didn't actually get this when you paused, that's okay, but it's good to think about it. So if the mean is 40, then we know that NP is 40, right? If the standard deviation of 6, then we know that the square root of NPQ is 6. Well, if this NP is 40, we can put a 40 in there for NP as well. So then we know that the square root of 40Q equals 6. Square both sides. 40Q equals 36. So Q is 36 over 40. If we divide by 4 on top and bottom, we get 9/10. Okay, which is the same as 0.9. So we found something. Now let's figure out what we were supposed to find. Oh, we were supposed to find N and P. That's not what we found. That's okay, because we know that N times P is 40. So if NP is 40, actually we can't do that one, right? Because we still don't have enough information. Wait a minute, what's P? Well, 1 minus 0.9 is what P is, because probability of success and failure have to add up to 1. 1 minus 0.9 is 0.1. So now if NP is 40, N times 0.1 is 40. Divide by 0.1, and that tells us that N is 400. So what we were looking for is P, which was 0.1, and N, which was 400. This type of example is a tad tricky. Please come to office hours and ask if you need help or just spend some time thinking about it. Thanks.